Hello everyone and welcome to Jacklet Educational Channel. So in this video we are going to discuss one of the very important topic related to environmental science entrance examination. So this will be considering the monitoring and testing of water. So water quality assessment, their monitoring and testing are the very important concept. So without wasting much time, let's start today's video. So I would like to say that every bit and tit I will be telling you, you should note it down because the questions will be asked from the conceptual purpose. So nobody will be asking you to perform the activity, to perform the reaction in the exam. So you should be clear with the fundamentals. So we should know what are the parameters for the water quality assessment. So here in this block we can see the physical parameters include temperature, color, odor, taste, turbidity, pH, conductivity, total dissolved solids. Similarly, inorganic or chemical components parameters include the hardness of the water, including calcium, magnesium, chloride, sulfate, fluoride, alkalinity, nitrate, and phosphate. Similarly, to manage the parameters related to toxic metals, the test will be having the test for copper, chromium, cadmium, zinc, lead, mercury, iron, and manganese. Similarly, if you are going to know about the bacteriological and assessing the water quality, you should be able to do the total coliform or fecal coliform count. So next thing we are going to see, that is the organic nutrient demand, that is BOD, COD, phenols, oil and grease, pesticide, nitrate. So here one of the very important thing will be the BOD and COD. So this thing, dissolved oxygen, BOD, COD, you would have heard since long from your school level exam. So now we will see what are the important terminologies and how to know the parameter testing and monitoring of water quality. So let's move to the next slide. So before knowing that, we should know the BIS, that is Bureau of Indian Standards, have certain parameters, certain limits for the drinking water in India. So these are very important. Please note it down in your notes. So first we will see for drinking water color. So the color means that they are analyzed using Hazen units. So Hazen units is having the parameter, the scale from 0 to 500. So you should note it down because pH scale you should know it is from 1 to 14. Similarly, Hazen units, that is considering the color of the drinking water, lies between 0 to 500. Next thing is, what is the desirable or acceptable limit of Hazen unit in the drinking water by BIS. So 5 should be the desirable or acceptable limit for the drinking water. But what is the permissible limit? So permissible limit is, if the Hazen unit is 15, then it is also permissible. That means if we are not having any alternate source in the place, then we can go for 15 Hazen units also for drinking. But if we are having the alternate source for the drinking water, then desirable or acceptable limit will be 5 units. So what we can do if we are not finding the correct color for the drinking water? So the treatment process include filtration, distillation process, as well as reverse osmosis technique. So by these three techniques we can be able to enhance the color, that is we can go to the zero limit. Zero limit means it is the more clear water, and 500 level is the most dirty water. Let's move to the order. So order you should sense by the help of nose, that we all know. So order should be agreeable. So those who are telling that we are able to order, that means the order is agreeable, it is not giving much bad order, then it is accepted for drinking water. So what can we do to treat the unagreeable or disagreeable order? So if the order is not good, what we can do? We can perform the activated carbon test, or we can do the air stripping test and oxidation test to treat the order, that is foul order, to make it good order. Next comes the pH value. So pH means it should be properly in between the acidic or alkaline levels. So the BIS says the standard is in between 6.5 to 8.5. So 6.5 means it is less than 7, it is not, it is the coming into the acid range, and 8.5 means it is coming into the alkaline range. So it should be in between this. So what is the relaxation? That means permissible limit. There is no permissible limit. They are telling that it must be between 6.5 to 8.5 for drinking purpose, the pH value. So what we can do if the pH is less? So if the pH is less of any drinking water, we can increase the pH by adding soda ash. And what to do if the pH is more? So we can decrease the pH by adding vinegar. So these are the treatment technique if we are not having the correct pH value of the drinking water. Next, coming into the turbidity. So turbidity is analyzed using NTU unit. So what is this NTU unit? So you would have heard several times, and this NTU means nephelometric turbidity units. So this is the important thing you should remember, and that unit will be, you should be 1 for the desirable limit for drinking water, and it should be 5 for the permissible limit of drinking water. So what we can do if the water is more turbid? So we should allow the water to settle down, and we can then filtrate it to reduce the turbidity. The next physical parameter for the water is TDS. Yes, TDS means total dissolved solids. So how much quantity of solids are dissolved inside the water. So it is expressed in milligram per liter, and the acceptable limit is 500 milligram per liter, and the permissible limit is 2000 milligram per liter as per the BIS-Quality standards. So what we can do if the TDS, that means dissolved solids, are more in the drinking water? So same thing we can do, that is reverse osmosis we can do to that water, distillation technique we can apply, or deionization technique we can do by ion exchange. So these are mostly ion, the solids which are present, so we can deionize them by using ion exchange technique. So I hope you would have noted down everything. Let's move to the next slide. Next slide is very important because here we are going to discuss the difference between DO, BOD and COD. So here DO means, we all know, that is dissolved oxygen. So how much quantity of oxygen is dissolved in the water, that gives the dissolved oxygen value. For example, this is our field site. So from here we are collecting the water. So then we have to check how much quantity of oxygen is dissolved in it. More the oxygen dissolved in it, better the water quality. Lesser the DO, the water quality is not good because the organisms will not be able to sustain there. Next comes BOD. BOD means biochemical oxygen demand. Similarly, COD means chemical oxygen demand. So why I have underlined oxygen demand? So this is the demand for oxygen. So who are demanding this oxygen? So we should know the correct definition of BOD is, it is the measure that the amount of oxygen required for the aerobic organism. Yes, these aerobic organisms present in the water, they demand for the oxygen for decomposing organic matter present in the water bodies. So how much of oxygen they need, that is the BOD. So if they need more oxygen, that means there is more amount of organic component present, that means the water is more polluted. So BOD, if it is more, then it is not good for the water quality. Similarly, what is COD? So as we can see, BOD means the amount of oxygen needed for the decomposition of organic matter. COD means the amount of oxygen required for the organisms present in the water to decompose both organic and inorganic constituent present in the water, that is the wastewater. So here that means the COD will be higher because it is having both the thing, considering organic and inorganic constituent, but BOD constitute or considers only the organic matter present in the water. So in some time the question is asked that BOD by COD ratio will be how much. So every time you should remember BOD by COD ratio will be less than 1. Why? Because COD is always higher because it is considering both organic and inorganic. So if the denominator is higher, the complete value will not be able to exceed 1. That means BOD numerator is less. So BOD by COD ratio will always be less than 1. Let's move to the next slide to know more deeply about these concepts. So here you should know that the process for estimating the dissolved oxygen, that is the standard process, is called as Winkler's method. So Winkler's method is used for determination of dissolved oxygen. So what is this method? So how to use this? So these are the process I have made it for you. First is we should collect the sample in BOD bottles. So you would have seen, so BOD bottles are like this one. So you should collect the water from the water site which you are going to analyze. Then what you have to do, you have to add 2 ml of manganese sulfate, MnSO4 you have to add in that bottle, that is BOD bottle. Then 2 ml of alkali iodide azide solution you have to add, and then we have to close the stopper. So stopper you are using to stop this. So what is this alkali iodide azide? So this is not a single chemical. So it can be made with the reaction of different chemicals. That means different alkali and iodide solutions. So I will give you an example that two kinds of alkali iodide solution can be made. That means so we can take NaOH, that is alkali, or KOH, that is potassium hydroxide. Along with that we can add NaI, that is sodium iodide, or we can add Ki, that is potassium iodide. So any one, NaOH plus NaI or NaOH plus Ki or KOH plus NaI and KOH plus Ki will give the alkali iodide. So alkali iodide is clear till now. That means alkali you should take any one, that is NaOH or KOH, and iodide should be NaI, that is sodium iodide or potassium iodide. What is this azide? So azide means NaN3. You should remember this is very important. Now these two things are added. Now what we'll do? We should mix it well. So mix that BOD bottle well. Allow the precipitate to settle. So if you are adding these compounds, then it will form the precipitate. So you should allow the precipitate to settle. Then what we will do? We will add 2 ml of concentrated H2SO4. So sulfuric acid we should add. Why? Because it will dissolve the precipitate. So the questions can be asked that why H2SO4 is used. It is used to dissolve the precipitate formed after adding MnSO4 and alkali iodide azide in the BOD bottle. Next what we will do? We will take 200 ml of that sample in a conical flask. From that BOD bottle, we will take 200 ml in a conical flask. And what we will do? So important thing for getting DO, BOD, we are able to do titration. So we must do titration, that to get the value of dissolved oxygen or biochemical oxygen demand. So what we have to do for titration? We will need a conical flask. So in the conical flask, we will take 200 ml of the mixture which we have prepared from the sample collected. And what next thing is, we should titrate against sodium thiosulfate. So sodium thiosulfate formula you should remember, Na2H2O3. I repeat, Na2H2O3 is the formula of sodium thiosulfate. So we will take 0.025 normality of the sodium thiosulfate, and what we will do, it will take in that burette. So in burette, sodium thiosulfate will be taken, and in the conical flask our sample is taken along with the reagent. Now what we will do, we should add certain indicator. So indicator is starch, and what it will do, that after this compound is formed in the conical flask, it will be blue in color. So what we will do, the starch will degrade the iodine content present in it, and it will turn into colorless. So colorless will be the end point. So don't worry, I will explain you with the help of the reactions which are taking place during this process. So let's move to the next slide. So this is the main thing which is taking place when we are doing the dissolved oxygen Winkler method. So what happens here, the sodium thiosulfate are in burette, and here the manganese sulfate, alkali iodide azide and H2SO4 are added to our water sample, for which we are going to analyze the dissolved oxygen. So what is happening is, when we are adding manganese sulfate with the alkali iodide, that is KOH, let us assume, it is forming MnOH whole 2 and K2SO4. Then what happens is, this MnOH whole 2. So what is this MnOH whole 2? So this MnOH whole 2 is having the manganese with the oxidation state of 2. So oxidation state of manganese is here 2. But this is reacting with the dissolved oxygen present in the water. So this thing we want to test, how much amount of oxygen is present. So this MnOH2 is forming reaction with the total dissolved oxygen present inside the water sample, and it is formed into 2MnOH whole 2, that is basic manganic oxide. Here the manganese, the oxidation state is +4, so it is oxidized. So this makes the brown color precipitate. So here this oxygen, you can see, this is the carrier oxygen. So you should remember that this is carrying, this manganese oxide is carrying the oxygen which we want to analyze. So it acts as a carrier. What happens next is, I will clear this. So what happens next is MnOOH2, that is holding our main thing, the main boss, that is oxygen, which we are going to calculate. Then when it is added with H2SO4, as we have known that we have to add H2SO4, then the precipitate, this thing is dissolved. and it breaks down into MnSO4, water and oxygen. This oxygen is called as nascent oxygen. So you should remember this is called specifically as nascent oxygen. So what happens in next step, that is the fourth step, the Ki is there. As we know, alkali iodide I have said. So Ki from the alkali iodide reacts with H2SO4 along with the nascent oxygen to give K2SO4, water and iodine. So here it is in ion form, here it is converted into iodine. It is formed as the gas, and this liberated gas is equivalent to the oxygen present in the water. You will say how it is equivalent, because this Ki reacts with the nascent oxygen, that is the oxygen present in the water, to give I2. That means we are considering, so equivalent amount of oxygen is present, as much amount of iodine is released as gas. So I hope you are clear. If you are not clear, you can comment me in the comment section. So next step is thiosulfate. So we have to titrate with this sodium thiosulfate. So amount of iodine is liberated. So if this iodine is reacted with sodium thiosulfate in the titration method, then it will give Na2S4O6 and 2NaI. So here that means this much, if we are knowing how much amount of sodium thiosulfate is used to neutralize or to cancel out this iodine, that much amount of oxygen is present, because iodine, as we have said, is equivalent to amount of oxygen present in the water which we are going to analyze. So amount of thiosulfate used is equal to amount of iodine reacted, and amount of iodine reacted is equivalent to amount of oxygen present. So for this, all these, it is known as fixing of dissolved oxygen. So we have to fix the oxygen. So it is not that match fixing. So these four steps are known as fixing of dissolved oxygen, because we want to fix the amount of oxygen present in the water, that is here. We don't want to include outside oxygen to interrupt the water sample which we want to analyze. So that's why these things are important. When we are at site, we should add these reagents, and then we can take the bottle, that is BOD bottle, to the lab and test it with the sodium thiosulfate titration technique. So I hope till now you are clear. Next, let's move on to the next slide. So we have done the titration. The sodium thiosulfate is consumed from the burette, the iodide is reacted, and we have to calculate what is the amount of dissolved oxygen present in it. So for that, this is the formula. So this is the Brahmastra. The formula is x multiplied by A multiplied by 8 multiplied by 1000 by V. So what is this x? So this x is the normality of sodium thiosulfate used. So as you can see, this normality we have used is 0.025. So that will be the normality. Next is A. So what is this A? So this A is volume of Na2H2O3 consumed. That is, from burette, how much amount of Na2H2O3 is used for the titration purpose. That is A ml of Na2H2O3 consumed. Next comes the 8. So why we are using 8? So 8 is actually the equivalent weight of oxygen. So we have to find the dissolved oxygen. So we have to multiply the equivalent weight of oxygen. So how to calculate it? I will tell you if you want to know. To calculate the equivalent weight of any atom, we should divide the atomic weight, that is atomic weight I am writing like this, divided by the valency. So here the atomic weight of the oxygen is 16 and the valency is 2, so we will get the value as 8. So 8 is the equivalent weight of oxygen. Next is we have to multiply it with 1000. So why we have to multiply? Because to convert it from gram to milligram, because the dissolved oxygen we have to find it in milligram per liter. Next is V. So what is this V? That is the volume of water sample taken. So how much amount of volume taken in the flask? That will be the VML. So I hope you are clear now. This is the total formula to calculate the dissolved oxygen. Now coming to the finding of BOD. So what is biochemical oxygen demand? How to calculate it? So this is very simple. This is nothing but, if you know the dissolved oxygen calculation as we have known till now, we can able to solve easily. But for that, one additional step is required, that is preparation of dilution water. So what is the dilution water? We will see. So this is the process to prepare dilution water for the BOD reaction. So what we have to do? We have to take 5 liters of double distilled water in a glass container. So distilled water, double distilled water we have to take in a container. We have to aerate the water with the clean compressed air for not less than 12 hours. That means minimum of 12 hours we have to incorporate air inside that distilled water. Then we have to allow it to stable down for at least 6 hours at 20 degrees Celsius. Next we have to add 5 ml of 27.5% weight by volume solution of calcium carbonate. Next we have to add 5 ml of 22.5% weight by solution of magnesium sulfate. And the next step will be addition of 5 ml of 0.15% weight by volume solution of ferric chloride. And then we will add 5 ml of phosphate buffer solution and mix the whole components and allow it to stand still for 2 hours. So in this way we will be able to prepare the dilution water. So I will tell you why this dilution water is prepared. So this is not at all containing our water collected from the waste side or our study side. This is the water only, that is double distilled water. So we'll see what is the use of this water. So this is the step for preparing BOD. Yes, what we have to do is we have to take 4 300 ml BOD bottles. So we have to take 4 bottles of BOD bottles and we have to add 10 ml of samples to 2 bottles. So in 2 BOD bottle we have to add 10 ml of the sample collected from the sample site, and the complete bottle will be again filled with the remaining volume of dilution water. So what is the dilution water? The water which we prepared in the previous slide, that is dilution water. So first we will fill the bottle, BOD bottle, with 10 ml of the sample water. Then we have to fill the complete bottle, that is 300 ml bottle, with the dilution water. That means, for example, approximately 290 ml we will add the dilution water. So I hope you are clear till now. Then what we will do, 2 bottles will remain it with as blank. So they are considered blank. So only they will consider the dilution water. They will not be having any water from the sample side. Next we will immediately close the bottles because we should not interfere any bubble to come inside or go outside the bottle. Then we will mark the bottle, what is blank and what is sample bottle. Then we will incubate the sample and blank bottle at 20 degrees Celsius for 5 days. So we have to incubate the samples for 5 days at 20 degrees Celsius. But before that, we have to analyze immediately the dissolved oxygen of the BOD bottle. So how to calculate DO? We have discussed. The same procedure we will apply and we will measure the dissolved oxygen before incubating. And then what we will do? We will analyze the bottle after 5 days. So one will be dissolved oxygen initial, that is DOI, before the time of incubation. One will be dissolved oxygen final, that is after 5 days of incubation. We will do the same procedure as we did for the determination of dissolved oxygen. So BOD will need the dissolved oxygen. So same thing we will follow, that is initial DO and final DO. So same procedure we will follow. And why we are doing this? Because this is the standard technique, that is the 5-day BOD is the standard technique to know the biochemical oxygen demand. So what is the calculation part? So here it is also very simple. I will tell you that the formula is for BOD-T, but here as we are taking 5 days of incubation, so for us it will be BOD 5 days BOD is standard. So it will be dissolved oxygen initial, that means before incubating we have taken the sample, so that DO will be dissolved oxygen initial minus dissolved oxygen final. That means after 5 days we will calculate the DO of that BOD bottle in which our sample is present, divided by the VS by VB. So it is the ratio, that means VS means sample volume. So how much sample we have taken? Let's go back and see. So we have taken the sample as 10 ml. And what is the other volume? So the other volume is VB. So VB is what? The bottle volume. So the BOD bottle is having the volume 300 ml. So here VS will be 10 ml divided by 300 in this case. But whatever you are taking, you can take the same value. So in this way we will get the DOI initial minus DOI final divided by this ratio, that is VS by VB, that is sample volume divided by the bottle volume. That will give the biochemical oxygen demand of the water sample which we are going to analyze. So that's all in this part of the video. If I am going to extend for COD, it will simply create havoc in your mind. So it is good to analyze this video and revise this. If you are having any doubt, you can ask in our Telegram group also. So the link is in the description below. And if you like this video, give a like and share it with your friends. And don't forget to subscribe the channel if you haven't subscribed till now.